20 teams have worked since the beginning of September to come up with innovative, efficient and affordable designs for off-grid populations. It's now time to announce the winning teams of the first year of the Efficiency for Access Design Challenge. Following their pitches to a panel of industry experts, 6 teams have been awarded with bronze, silver and gold. And it brings me great pleasure to be announcing these winners today. And the first bronze award of the Efficiency for Access Design Challenge 2020 competition goes to Team 017 from Strathmore University with Kijiji, a solar-powered container with essential services for empowering rural communities.
Kijiji is supported by 2 key components. 1, selling energy and space for incubation of rural areas and rural businesses. And 2, an Uberized concept where we deliver batteries in household areas that are far from the solar-powered container. So what is going to happen in this container? We're basically going to have services like health, education, businesses, and agriculture. Knowing that most of the people get most of their money from agriculture products, of course, we will not leave this behind. Now, having a one-stop shop for all local businesses to thrive in a village, this modular nature of a solar-powered container will have different business units which are easy come and go. So basically where one fails to survive, it's easy to replace with another business. And 2, we're looking at a model that can be resold after its lifetime and also recycled for other services thereafter.
Congratulations to Team 017. Now the second bronze award of the Efficiency for Access Design Challenge 2020 competition goes to Team 020 from Bath University with their off-grid refrigeration solution. Congratulations.
So when deciding which off-grid opportunity to explore, refrigeration stood out to us the most. The fridge alone consumes more than double the energy of all other household appliances combined.
This is the refrigerator that we've been working on called ACE, which stands for Activated Carbon Ethanol, the name being inspired from the cooling technology. The features highlighted on this slide heavily affect the usability and manufacturability of our design. The refrigerator is split into 3 sections comprising of an adjustable upper humidity box, upper basket and lower basket.
The technology works using ethanol and activated carbon as the working pair, which are both non-toxic and environmentally benign, which really helps us provide an environmentally friendly solution. And I think the main benefit of this technology is that a solar thermal collector can be used to power the refrigerator with quite high efficiency, allowing it to actually run without any access to electricity at all.
The first silver award of the Efficiency for Access Design Challenge 2020 competition goes to Team 016 from the University of Strathclyde with their project eCook for developing countries.
Our solution to this global problem has been to explore electric cooking in areas where cooking with electricity is not currently available or practical to use. Specifically, we set out to design an electric cooking device that can be used with typical solar home systems and microgrids that are found increasingly commonly in parts of the developing world where electric cooking might not currently be available.
As part of the design process, we kept in mind the cultural needs of the end user, including the kinds of food we anticipate people will be cooking and the methods they would traditionally use to cook them.
Our solution is an electric cooking device that uses the heat dissipated from current conducting diodes to power a hot plate. The diodes were chosen as the heat source for the device as they are cheap and heat up significantly at relatively low power. The diodes used in the cooker were selected after several different types were tested. This testing was used to determine the highest temperatures the diodes produced at various power levels. A removable layer of insulation was also included as part of our design to improve the thermal efficiency of the device during cooking.
Huge congratulations to Team 016. Our second silver award of the Efficiency for Access Design Challenge 2020 competition goes to Team 002 from Carnegie University with the design of a solar energy efficient fish dryer. Congratulations.
Fishing sector remains the highest second foreign exchange earner for Uganda, according to the Uganda Investment Authority. Despite large amounts of fish caught, there is still no processing of fish. We have fish spoilage that is caused by microorganisms. Then there is poor handling of this fish. We have solar thermal system and a solar PV system. At this point, this is a solar PV system, and then down we have a solar thermal system. It gets rays from the sun that are received by the concentrator. The concentrator is directed to send the rays to a collector. Solar collector heats up, and then there is a fan, an actual fan that is aiding the flow of heat from the solar collector, the drying cabin that is at this point.
It is now time to announce the two winners of the Gold Award of the first edition of the Efficiency for Access Design Challenge. And the first recipient of the Gold Award is Team 001 from Makerere University with their standalone solar load management system. Congratulations to the team.
So how is this going to work? So we are going to categorize the DC loads that are connected to this solar supply into priority, intermediate, and non-priority loads. So then once the priority loads have been identified, we shall program a microcontroller to cut off the current going to the non-priority loads in case the battery capacity has reached a certain minimum value that we've determined in our program.
Let's take a look at what the customer will be benefiting from using the standalone load management system. So the loads will be managed efficiently and appropriately, which leads to longer energy supply times and also the cost spent on fuel. For example, the fuel costs of a diesel generator will be reduced because the available solar energy will be available for longer hours than usual.
And our second gold awardee of the 2020 edition of the Efficiency for Access Design Challenge is Team 003 from University College London with their project Off-Grid Electric Pressure Cookers for Sub-Saharan African Communities. Congratulations to the team.
Looking specifically at a current readily available electric pressure cooker, or EPCs, they're generally very energy efficient, but designed for AC electricity, provide time savings, but can also be costly. Even at the lowest energy consumption, they're not quite compatible with off-grid solar home systems.
So for example, including a float valve and steam release valve to regulate and mitigate any dangerous pressures, and the pin lock and push button to ensure that the EPC can only function when it is properly closed.
For marketing and adoption strategies, working on the three elements shown provide the crucial base for intervention. Demand can be enhanced by tackling the price barrier through the pay-as-you-go schemes, and to strengthen the supply, the Rwanda's social governance structure provides the entry point to reach for all customers. Through these structures, monthly meetings to raise awareness and conduct EPC demonstrations can be held, which will eventually foster an enabling environment for the EPC.
Congratulations to all awardees and to all participants in this inaugural year of the Efficiency for Access Design Challenge. All our industry experts were delighted and incredibly enthusiastic about the quality of work and projects that have been submitted. So we'd like to thank you all for participation in this inaugural year of the competition.